At 1,647 hours on March 18, 1943, aviation machinist's mate first class Raymond Harwell stood at the edge of Henderson Field's taxiway and watched Lieutenant James Hagan's F4U Corsair limp toward the hardstand. The engine was trailing white smoke. Hydraulic fluid streaked back from the cowling, painting dark lines across the inverted gull wings. 23 bullet holes punctured the engine cowling in a tight group. Center mass. Good shooting. Hagan cut the engine at the revetment. The massive three-bladed propeller windmilled to a stop. The silence felt wrong. Corsairs were supposed to sound powerful, dominant. This one sounded tired. Hagan climbed out of the cockpit. His hands were shaking. His flight suit was dark with sweat despite the humidity. He was 24 years old. Looked 40 right now. "It wouldn't run," Hagan said. His voice was flat. "Mechanical. I had full throttle. 2,800 revolutions per minute. Manifold pressure at 52 inches. By the book. It just wouldn't run." Harwell grabbed his toolbox. The metal handle was hot from sitting in the tropical sun. "How many were on you?" 2. "Zeros. I should have outrun them. Should have gapped them by 50 yards in the first 10 seconds. They stayed with me for 40 miles. Harwell pulled the cowling release. The metal was still hot from the engine. The smell of burned oil and hydraulic fluid filled his nose. Aviation fuel. Cordite. The smell of an aircraft that had been in combat. He looked at the bullet holes. 7.7 millimeters. Japanese machine gun rounds. They'd punched through the cowling but missed the engine. Missed everything critical. Pure luck. "Go debrief," Harwell said. "I'll find it." Hagan looked at him. "You think there's something to find?" "There's always something." Harwell's hands were already moving, checking oil levels, feeling for stress cracks, running fingers along fuel lines. 28 years old. Grease permanently embedded under his fingernails. 5 years maintaining aircraft. The last 8 months maintaining Corsairs. He knew these machines better than the engineers who designed them. The F4U Corsair was supposed to change the war. On paper, it was the most advanced fighter aircraft in the Pacific theater. The Pratt Whitney R-2800 double Wasp engine produced 2,000 horsepower, 400 more than any Japanese fighter. The distinctive inverted gull wing design allowed the massive 13-foot Hamilton Standard hydromatic propeller to clear the deck during carrier landings. Factory specifications promised 417 miles per hour in level flight, 200 miles per hour faster than a Zero. The Corsair was supposed to dominate Japanese fighters the way a truck dominates a bicycle. Marine Fighter Squadron VMF 124 had received their first Corsairs in January 1943. The pilots were excited. Finally, an aircraft that could outrun, outclimb, and outfight anything the Japanese had. Finally, they'd stop losing pilots to Zeros that could turn inside them and shoot them down. By March, VMF 124 had lost 11 Corsairs in combat. 8 of those 11 were caught from behind by aircraft they should have easily outrun. Pilots consistently reported the same thing. The aircraft felt like it was straining, like something was holding it back. Like they were asking for 417 miles per hour and getting 380. 37 miles per hour might not sound significant, but in combat, 20 miles per hour was the difference between escaping and dying. 37 miles per hour was the difference between controlling the engagement and being controlled by it. The official response from engineering was simple. The aircraft met factory specifications. Ground tests confirmed top speeds of 417 miles per hour. If pilots couldn't achieve that in combat, the problem was pilot technique, not aircraft performance. Command blamed tactics, poor engagement discipline, failure to maintain proper speed management. Maintenance officers blamed the crew chiefs. Inadequate servicing, improper engine timing, substandard, pre-flight inspections. Everyone blamed everyone except the aircraft. And pilots kept dying. Lieutenant Thomas Mercado died February 4th over New Georgia. 4 Zeros bounced his 2-ship flight at 12,000 feet. Standard escape procedure. Push throttle forward, dive away. Use speed advantage to extend out of range. Mercado did everything right. Called the threat, rolled inverted, pulled into a high-speed dive. The Zeros stayed with him. His wingman heard it over the radio. "I'm at full military power, they're still closing." The Zeros shot Mercado down at 8,000 feet. He never had a chance. The wreckage burned in the jungle. The Navy sent a letter to his family in San Diego. Killed in action. Distinguished himself through courage and devotion to duty. Mercado's crew chief was Staff Sergeant Mike Rodriguez. Rodriguez had signed off on Mercado's aircraft that morning. Everything perfect. Engine compression. 178 pounds per square inches across all 18 cylinders. Magneto timing within 0.5 degrees. Fuel. Pressure. 14.2 pounds per square inches. Oil temperature. 180 degrees Fahrenheit at idle. Rodriguez told Harwell the night Mercado died. "I checked everything. Twice. There was nothing wrong with that aircraft." Harwell believed him. Rodriguez was thorough. Competent. If Rodriguez said the aircraft was airworthy, it was airworthy. So why had it killed Mercado? Captain William Morrison died February 22nd. Second death, same problem. Morrison was a flight leader. Experienced. 11 confirmed kills. He knew the Corsair inside and out. Knew its strengths, knew its limitations. Flew smart. On February 19th, Morrison's 4-ship flight intercepted 6 Zeros over Vela La Vela. Morrison got one on the first pass. Textbook bounce from altitude. Came around for a second run. 2 Zeros reversed on him. Morrison tried to extend away. Called over the radio that his aircraft felt sluggish. Like it wasn't accelerating properly. The Zeros damaged his aircraft, but Morrison limped home. 47 bullet holes. None. Critical. Morrison told the debriefing officer, "Aircraft wouldn't accelerate like it should. Felt like I was dragging something." 3 days later, Morrison flew another mission. Same squadron, same aircraft, same problem. This time the Zeros didn't just damage his aircraft, they shot him down. Morrison died in the crash. The official report said pilot error during defensive maneuvering. Morrison's wingman said the aircraft wasn't responding fast enough. Ensign Robert Chen died March 12, 22 years old. From Sacramento, California. Chen had talked to Harwell the night before his last mission. They'd stood in the maintenance area after sunset. The air smelled like aviation fuel and tropical flowers. Chen was worried about his aircraft's performance. "Feels like the prop's not biting," Chen said. "Like it's slipping. Not getting good purchase on the air." Harwell had checked Chen's aircraft twice. Propeller governor functioning normally. Blade pitch angles within specification. Oil pressure to the propeller hub. 285 pounds per square inches. Everything perfect. "Fly it tomorrow," Harwell said. "If it still feels wrong, I'll pull the whole propeller system." Chen nodded. Walked back to the ready room. The next day, 3 Zeros caught Chen at 9,000 feet. Chen tried to dive away. The Zeros stayed with him. Harwell watched the whole thing from the control tower. Watched Chen's Corsair straining to build speed. Watched the Zeros closing. Watched Chen die. Chen's last radio call, "I can't get away from them." That night, Harwell sat in the maintenance area and stared at Chen's aircraft. Perfectly maintained, perfectly functional, perfectly deadly. 11 pilots dead in 3 months. Something was wrong, and Harwell was going to find it. Raymond Harwell learned about propellers from Frank Holloway at American Airlines' Tulsa maintenance facility in 1936. Holloway was 58 years old. Chief propeller mechanic, 32 years maintaining aircraft, starting with wood propellers on Jenny, biplanes after World War I. Holloway had forgotten more about propellers than most engineers ever learned. Harwell was 21, fresh out of trade school, eager. Holloway took him under supervision. "Specs are for engineers," Holloway said the first day. "Reality is for mechanics. Engineers design it in California. We make it work in Oklahoma." There's a difference. Harwell spent 7 years working on DC-3 propellers. Hamilton Standard constant speed models. Same manufacturer as the Corsair propellers. Same basic hydraulic pitch change mechanism. Different size, same principles. He learned blade pitch theory. How propeller blades work like wings, creating lift that translates into forward thrust. How pitch angle determines efficiency at different speeds. How the wrong angle turns a propeller into a brake. He learned it tactilely. Through his hands. Through 2,400 hours of maintenance work. Through the feel of a properly tensioned pitch change mechanism versus one that was starting to wear. Through the sound of a propeller under load, the specific note it made when everything was right. Holloway taught him to trust his hands more than the specifications. Manuals tell you what should work, Holloway said. Your hands tell you what does work. Listen to your hands. When Pearl Harbor happened, Harwell enlisted. Navy. Aviation machinist rating. They sent him to Advanced Propeller Maintenance School at Naval Air Station Jacksonville. 6 weeks. He already knew everything they taught. Finished top of his class. January 1943. Assigned to Marine Fighter Squadron VMF 124, Henderson Field, Guadalcanal. The other crew chiefs knew Harwell's reputation within 2 weeks. He found problems others missed. A worn bearing in a propeller governor that would have failed in 3 more flights. A microscopic crack in a blade root that would have propagated into catastrophic failure. An oil pressure regulator that was within specification but operating at the edge of tolerance. Pilots requested him specifically for pre-flight inspections. They trusted him. Trusted that if Harwell signed off an aircraft, that aircraft was truly airworthy. Other crew chiefs asked his advice. Rodriguez, Staff Sergeant Tommy Wilson, Aviation Machinists Mate 2nd Class Dave Patterson. When they found something they didn't understand, they brought it to Harwell. Harwell followed regulations. Always. Every inspection by the book. Every maintenance procedure exactly as specified. Every signature on every log legitimate and accurate. He'd never violated a regulation in his career. Not until Chen died. Harwell started at 1,800 hours. 6 hours until midnight. 6 hours to find what was killing pilots. He pulled Hagen's Corsair into the maintenance hangar. The overhead lights cast harsh shadows across the engine. The air smelled like oil and metal and the ocean 200 yards away. First, engine compression check. Harwell removed all 18 spark plugs. Threaded the compression tester into each cylinder. Cranked the engine manually. Watched the gauge. Cylinder 1. 178 pounds per square inches. Cylinder 2. 180 pounds per square inches. Cylinder 3. 177 pounds per square inches. All 18 cylinders between 175 and 182 pounds per square inches. Specification called for 170 to 185 pounds per square inches. Perfect compression. Second, magneto timing. Harwell rotated the propeller to top dead center on cylinder 1. Checked the timing marks. Left magneto, 28 degrees before top dead center. Right magneto, 28 degrees before top dead center. Specification, 28 degrees plus or minus 0.5 degrees. Perfect timing. Third, fuel system. Harwell checked fuel pressure at the carburetor, hand-pumped the wobble pump, watched the gauge climb. Stabilized at 14.2 pounds per square inches. Specification, 14.5 pounds per square inches. Perfect fuel pressure. Fourth, propeller governor. Harwell disconnected the governor control cable. Manually actuated the governor. Felt the resistance. Smooth. No binding. No excessive play. Reconnected the cable. Checked the rigging. Governor arm moved exactly 42 degrees from low pitch to high pitch. Stop. Specification. 42 degrees plus or minus 2 degrees. Perfect governor operation. By 2100 hours, Harwell had checked every system. Everything was within specification. Everything was perfect. The aircraft should have worked. But it hadn't. Harwell sat on the hangar floor, his back against the Corsair's main landing gear. His coveralls were soaked with sweat. His hands were black with grease. He stared at the propeller, 13 feet in diameter, 3 blades. Each blade weighed 47 pounds. Hamilton Standard Hydromatic Constant Speed Propeller. Hydraulic pitch change mechanism. Oil pressure from the engine drove a piston that rotated the blades. Blade angle changed automatically to maintain constant RPM regardless of airspeed. At least, that's how it was supposed to work. Harwell stood up, grabbed the tip of one propeller blade, pulled down hard. The blade flexed slightly. Maybe a quarter-inch of movement at the tip. He released it. The blade sprang back. He pulled again, harder this time. Felt the resistance. Felt the blade flex. Felt something else. Something wrong. He grabbed a flashlight, crawled under the propeller hub, shined the light up into the mechanism. The pitch change mechanism was a complex assembly of pistons, gears, and hydraulic lines. The blades rotated on bronze bushings inside the hub. A mechanical stop limited the rotation, a hardened steel pin that prevented the blades from rotating past a certain angle. Harwell found a wrench, removed the inspection cover on the hub, reached inside, felt the pitch stop pin with his fingers. The pin was there. Solid. Exactly where it should be. But Harwell noticed something. When he pulled on the blade, creating artificial load, the blade flexed before it hit the stop. Not much. Maybe 1/8 of an inch at the hub. But 1/8 of an inch at the hub translated to 3 or 4 inches at the blade tip. And 3 or 4 inches at the blade tip changed the effective blade angle by several degrees. He did quick math in at his head. Static blade pitch angle, 32 degrees. Measured on the ground, no load. Under combat power and high airspeed, aerodynamic forces on the blade would be enormous. Forces trying to flatten the blade angle. Forces creating flex in the blade and the mounting system. Harwell estimated the forces. He'd felt them thousands of times on DC-3 propellers. Knew how much pressure it took to deflect a blade. Knew that combat power on a Corsair 2,800 revolutions per minute, 52 inches of manifold pressure, 400 miles per hour created forces maybe 400 times stronger than what his hands could generate. If his hands could deflect the blade enough to change the angle by 1 degree, combat forces could change it by 4 or 5 degrees. Effective blade angle under combat load, approximately 27 degrees. Harwell pulled out his maintenance manual, found the propeller efficiency charts, ran his finger down the table. Optimal blade angle for high-speed flight, 38 to 40 degrees. Actual blade angle under combat. Load, 27 degrees, 11-degree deficit. That was the problem. The propeller blades were operating at completely wrong angle under the conditions that mattered most. The specifications measured blade angle on the ground, static, unloaded. Nobody had accounted for blade flex under combat power. The propeller was acting like a brake, absorbing power instead of converting it to thrust efficiently. Harwell checked his watch. 2,145 hours. He knew how to fix it, and he knew fixing it would end his career. Harwell sat in the hangar and did the calculation that mattered. Risk. Court-martial. Dishonorable discharge. Federal prison, possibly. Reward. Hagen lives. Other pilots live. The arithmetic was simple. 11 pilots dead in 3 months. If the problem wasn't fixed, the pattern would continue. 4 pilots per month, 48 pilots per year. VMF 124 would be dead in 8 months. Balanced against that, 1 mechanic's career. The equation solved itself. Harwell pulled his toolbox closer, selected a set of precision files, removed the propeller hub inspection cover completely, set it aside on a clean rag, 2,230 hours. The hangar was empty. Night maintenance shift didn't start until 0200 hours. He had 3.5 hours. The pitch control mechanism had a tamper-evident seal. Red wax stamped with US Naval Air 4471A. The seal covered the access panel to the pitch stop mechanism. Breaking the seal without authorization was a federal offense under wartime regulations. Harwell broke it. He used a thin blade to slice through the wax, removed the access panel. Inside, the pitch stop assembly. A hardened steel pin, 0.375 inches in diameter, protruded from the hub housing. When the propeller blades rotated to maximum pitch angle, a lug on each blade struck this pin. The pin prevented further rotation. Harwell measured the pin with calipers. Length, 0.625 inches from the housing face. He removed the pin, required 3 Allen bolts, each bolt torqued to 45 foot-pounds. Harwell broke them loose, unscrewed them by hand, pulled the pin free. The pin was pristine, no wear, no damage, exactly as manufactured. Harwell clamped the pin in a vise, selected a fine-tooth file, started removing material from the end of the pin. He worked carefully, checked progress every 30 seconds with the calipers. He needed to remove exactly 1/16 inch, 0.0625 inches. Remove too much and the blades might overstress. Remove too little and the problem wouldn't be solved. The filing took 18 minutes. His hand cramped twice. He stopped, stretched his fingers, continued. Final measurement. Pin length, 0.5625 inches. Exactly 1/16 inch shorter than specification. Harwell cleaned the metal filings from the pin, wiped it with a clean rag, threaded it back into the hub housing. Torqued the Allen bolts to 45 foot-pounds, double-checked with a torque wrench. The shorter pin would allow the propeller blades to rotate to a higher pitch angle. On the ground, the blades would measure approximately 35 degrees 4 degrees over specification. Under combat load, when the blades flexed, they would end up at approximately 38 to 40 degrees. Optimal angle for high-speed flight. Harwell replaced the access panel. The problem, he'd broken the tamper-evident seal. He needed a new seal, but seals were serialized, tracked, accounted for. He couldn't requisition a new seal without explaining why he needed one. So he made one. He found red wax in the machine shop, used a knife to carve US Naval Air 4471A into a small piece of aluminum, heated the wax, pressed it over the access panel, stamped it with his makeshift die. The result looked authentic, wouldn't pass close inspection with magnification, but would pass a visual inspection from 3 feet away. Harwell replaced the hub inspection cover, cleaned his tools, checked his watch. 2,315 hours. 37 minutes start to finish. He walked to the maintenance log, opened to Hagen's aircraft page, wrote, "Propeller inspection, complete. All systems within tolerance. Aircraft airworthy." Signed, AMM-1R. Harwell, 18 March 1943, 2,315 hours. The signature felt heavier than usual. He tore a page from his notebook, wrote, "Try full throttle at altitude. Let me know what happens." Walked out to Hagen's aircraft, put the note in the cockpit, weighted it down with the pilot's kneeboard so it wouldn't blow away. Then Harwell walked to his tent, lay on his bunk, stared at the canvas ceiling, didn't sleep. Hagen arrived at the flight line at 0545 hours. The sun was just breaking over the horizon. The air was cool. Would be hot by 0800. Always was. He walked past 3 Corsairs to his aircraft. Number 23. White numbers painted on the cowling. His assigned bird for the past 2 months. The note was sitting on the seat. Hagen picked it up. Read it. Read it again. He found Harwell in the maintenance area. Harwell was checking oil levels on another Corsair. His hands were already black with grease. "What did you adjust?" Hagen asked. Harwell kept working. Didn't look up. "Might help, might not. That's not an answer. It's the only answer you're getting." Hagen stepped closer. Lowered his voice. "Ray, what did you do to my aircraft?" Harwell finally looked at him. "Better you don't know. If something goes wrong, you didn't know about it. You just flew the aircraft that was assigned to you. That's all anyone needs to know." Hagen stared at him for 10 seconds. Understanding passed between them. Hagen had been flying long enough to know what unauthorized modifications meant, what they could mean for the mechanic who made them. "Okay," Hagen said. "You don't have to fly it," Harwell said. "I can swap you to another aircraft. Take 30 minutes. Hagen's voice was firm. "If you think it'll help, I'll fly it." Harwell nodded once. "Report back on performance. Exact numbers, if you can get them." Mission briefing was at 06:15, 5 hours in the ready room. Major Donald Webb ran the briefing. Webb was 31, Squadron Operations Officer. Calm, thorough, trusted by his pilots. "Combat Air Patrol," Webb said. "Convoy protection. 12 Liberty ships heading northwest toward Munda Point. Japanese have been hitting convoys in that sector. Intelligence expects bomber activity, probably Betties, possibly escorted. 4 Corsairs would fly top cover, Hagen as flight leader. Lieutenants Frank Mitchell, Dave Richardson, and Tom Bailey as wingmen. Standard formation. Standard patrol pattern, 8-hour mission including transit time. Expected enemy activity, moderate. Enemy strength, unknown until contact." Webb finished the briefing. "Questions?" Nobody spoke. "All right, man your aircraft. Wheels up at 0645. Hagen walked out to his Corsair at 0635 hours, did his exterior pre-flight, checked the control surfaces, checked the landing gear, checked for fuel leaks, hydraulic leaks, oil leaks. Everything looked normal. He climbed into the cockpit, strapped in, 5-point harness, shoulder straps, lap, belt, crotch strap, pulled them tight, started the engine at 0640 hours. The R-2800 caught on the fourth blade, 18 cylinders firing in sequence. The noise was overwhelming even with his headset on, 2,000 horsepower shaking the entire aircraft. But something was different. Hagen had started this engine 60 times, knew its sound, knew its rhythm. This morning it sounded different. Not wrong, just different. The propeller pitch seemed slightly coarser, the RPM note slightly lower at idle. Richardson's voice crackled over the radio. "Lead, your prop sounds weird," Tower responded. "Say again?" Richardson hesitated. "Nothing. Probably nothing." Hagen didn't respond. He checked his instruments. Oil pressure, 65 pounds per square inches. Oil temperature, 40 degrees Celsius, climbing. Manifold pressure, 30 inches. RPM, 1000. Everything normal. Tower cleared them for takeoff at 0642 hours. 4 Corsairs taxied to the runway, Hagen in the lead, Mitchell on his wing, Richardson and Bailey behind. Hagen pushed the throttle forward. The Corsair accelerated. Tail came up at 40 knots, lifted off at 95 knots, gear up at 400 feet. The climb felt stronger, more eager. Like the aircraft wanted to fly. Hagen couldn't explain it. But he felt it. Section 8. First combat test, E-engagement, 700 words. At 0847 hours, radar picked up contacts. Henderson Field Control, Tombstone Flight Contact. Bogies bearing 330, Angels 15, range 4 to 0 miles. Hagen. Copy. What's the count? 12 contacts, probably fighters. 12 aircraft. Hagen's flight was at 18,000 feet. Altitude advantage. Standard tactical position. If the contacts were zeros, and they probably were standard, doctrine was clear. Dive from altitude, build speed, make one pass, extend away, don't get caught in a turning fight. The doctrine assumed Corsairs could extend away, assumed their speed advantage worked. For the past 3 months, that assumption had been killing pilots. Hagen checked his fuel. Checked his ammunition. 6. 50 caliber machine guns. 400 rounds per gun. 2,400 rounds total. Tombstone flight, tally, Mitchell called. 12 bandits, Angels 15, 6 o'clock low. Hagen looked down, saw them. 12 zeros in loose formation. Dark green paint. Rising sun insignia visible even from 3 miles away. Tombstone flight. We're going in, Hagen said. Standard bounce. Dive. Attack. Extend. Stay fast. Do not. Repeat. Do not get slow. 3 acknowledgements clicked over the radio. Hagen rolled inverted. Pulled. The Corsair's nose dropped toward the zeros. Gravity and engine power accelerated the aircraft. Speed built quickly. 250 knots. 280. 300. Hagen picked his target. A 0, at the back of the formation. The pilot probably hadn't seen them yet. Probably didn't know 4 Corsairs were diving on him from 3,000 feet above. 320 knots. 340. 360. The airspeed indicator climbed past 380 knots, the speed Corsairs normally topped out at in combat. But the needle kept moving. 390 knots. Hagen felt it immediately. The aircraft was accelerating harder than it ever had. The engine note was different, smoother, more efficient, like a car shifting from 3rd gear into 4th. 400 knots. The 0 grew rapidly in his gun sight. Hagen had made this type of attack 50 times. He knew the closure rate, knew how fast targets should grow in his sight picture. This was faster. He opened fire at 800 yards, long range. Normally he'd wait until 400 yards. But the closure rate was so high he had to start early. 6, 50 calibers hammered. Tracers reached out. Most missed, a few connected. The Zero's left wing root sparked, then exploded. Pieces flew off. The 0 rolled inverted and fell. Hagen didn't watch it fall. He was already pulling out of the dive. Throttle to full military power, climbing away. 410 knots. He'd never seen 410 knots. Not in combat. Not with ordnance on board. Not in humid tropical air. But the airspeed indicator read 410. 2 Zeros tried to follow him. They rolled to pursue, started climbing. Hagen watched them over his shoulder, watched the distance between his aircraft and theirs. The gap opened. 50 yards in the first 5 seconds. 100 yards in 10 seconds. After 15 seconds, the Zeros gave up, broke off, couldn't maintain the chase. Mitchell's voice crackled over the radio. Lead, how are you doing that? You just gapped them by 200 yards in 10 seconds. I have no idea, Hagen said. Aircraft's running like a scalded cat. Bailey. Your prop. Listen to it. Higher pitch at speed. Different sound. Hagen listened. Bailey was right. The propeller sounded different, not laboring, not straining, just efficient. Richardson. Whatever Harwell did, it's working. Hagen checked his altitude. 17,000 feet. Still plenty of energy. Reform on me. We're going back in. The engagement lasted 18 minutes. Hagen's flight made 4 attack runs. Each time, dive from altitude, build speed, fire, extend away. Zeros tried to counter, tried to turn with them, tried to stay with them in the extensions, couldn't. Every time the Corsairs extended, they pulled away. Every time they climbed back to altitude, they did it faster than the Zeros could follow. The speed advantage finally worked the way it was supposed to. Hagen got 2 more Zeros. Mitchell and Richardson each got 1. Bailey damaged 2 others. Final count, 5 Zeros confirmed destroyed. 2 damaged. 0 Corsair losses. 0 Corsair damage. At 0912 hours, the remaining Zeros broke off completely. Headed northwest toward their base at Bougainville. Hagen had never seen Zeros retreat before. Tombstone flight, return to base, he called. Good shooting. He checked his fuel. Enough for 1 hour. Pointed his Corsair southeast toward Henderson Field. The entire flight home, he thought about one thing. What the hell did Harwell do to this aircraft? Section 9. Post-flight analysis. 500 words. Hagen landed at 09:27 hours, taxied to his revetment. Harwell was waiting. Hagen shut down the engine. The propeller windmilled to a stop. He sat in the cockpit for a moment. His hands weren't shaking. First time in a month his hands hadn't shaken after combat. He climbed out. His flight suit was soaked with sweat. His legs were shaky. Adrenaline wearing off. Harwell stood 3 feet away. Grease-stained coveralls, face carefully neutral. "What did you do to my airplane?" Hagen asked. "Did it work?" "I hit 415. In combat. With external tanks still attached. I've never seen 415. Ever." Harwell nodded slowly. "Good. Good? That's all you have to say? Did you get anyone?" 3. Mitchell and Richardson each got 1. Bailey damaged 2. "Anyone hit us?" "No. We were too fast. They couldn't stay with us." "Ray, what did you do?" Harwell looked at the propeller. "I adjusted the pitch stops. Blades run at a different angle now. Better angle for high-speed flight." "That's a sealed system. You're not authorized." "I know." Hagen stared at him. "You broke regulations." "Yes." "You could get court-martialed." "Yes." "Why?" Harwell met his eyes. "Because Chen died. Because Morrison died. Because Mercado died. Because watching pilots die when I can fix the problem is worse than getting court-martialed." Hagen didn't know what to say to that. "Go debrief," Harwell said. "Tell them what you want. I'll deal with the consequences." The debriefing was at 1015 hours. Major Webb ran it. Standard format. Each pilot reported their engagement, times, altitudes, headings, enemy count, results. When Hagen's turn came, he described the mission. 4 aircraft, 12 zeros, 5 kills. 0 losses. Then he added, "Aircraft performance was significantly improved over previous missions. Top speed approximately 415 knots at 15,000 feet. Acceleration in level flight approximately 30% better than normal. Recommend investigation of whatever caused the improvement." Webb looked up from his notes. "Explain." "Aircraft performed better than it ever has. Faster, more responsive. Whatever's different, we need to know what it is." Webb made a note. "I'll have engineering look at it." Mitchell spoke up. "Sir, it wasn't just Hagen. We all heard it. His propeller sounded different, like it was running at a different pitch." Webb looked at Mitchell, then at Hagen. "Different how?" "Coarser pitch at high speed. Like it was biting the air better." Webb closed his notebook. "I'll talk to Harwell." At 1100 hours, Webb found Harwell in the maintenance area. "What did you do to Hagen's aircraft?" Harwell made a choice. Lie or tell the truth. Lying might protect him temporarily, but the truth would save more pilots. "I adjusted the propeller pitch stop mechanism." Webb's expression didn't change. "That system is sealed. Depot-level maintenance only." "Yes, sir." "You're telling me you performed unauthorized modifications to flight-critical systems?" "Yes, sir." Silence. 15 seconds. 20. Then Webb asked, "Can you do it to my aircraft?" Webb stood in the maintenance area. Afternoon heat made the metal hangar walls radiate warmth. The smell of aviation fuel hung in the air. "You understand what you're asking me to do," Harwell said. "I understand you just saved Hagen's life, and Mitchell's, and Richardson's. I understand 5 zeros went down this morning, and none of my pilots got scratched." "Sir, if this goes wrong—" "Then we both go down," Webb interrupted. "I'm asking you to make an unauthorized modification. I'm ordering you to keep it quiet." "That makes me complicit. That makes me just as guilty as you are." Harwell looked at him. Webb was 31 years old, career officer, academy graduate, by-the-book leadership for his entire career. This was different. This was choosing pilots over regulations. "How many aircraft can you modify per night?" Webb asked. "Working alone? 2? Maybe 3 if I push it. Get started. Log it as routine propeller maintenance. Tell no one what you're actually doing. The other mechanics will notice. Then tell them it's classified. Tell them it's a field test. Tell them whatever keeps them from asking questions." Webb paused. "Start with my aircraft tonight." Harwell worked alone that night. 2,200 hours, to 0400 hours, 6 hours, 3 aircraft. First, Webb's Corsair, number 17. Harwell pulled the hub inspection cover, broke the seal, removed the pitch stop pin, filed it down 1/16 inch, reinstalled, made a new seal, replaced the cover. Time, 35 minutes. Second, Mitchell's aircraft. Number 8. Same procedure. His hands moved faster now, muscle memory from the previous night. Time, 32 minutes. Third, Richardson's aircraft. Number 14. Harwell's hands were cramping, the file was getting dull. He had to push harder to remove material. Time, 41 minutes. 3 aircraft modified. 3 pilots who might live through the next engagement. Staff Sergeant Tommy Wilson found Harwell at 0230 hours. Wilson was the night shift supervisor. Good mechanic. Curious about everything. "What are you doing?" Wilson asked. "Propeller inspection." "On 3 aircraft?" "At 0230? Found an issue on Hagen's bird yesterday, checking if it's fleet-wide." Wilson looked at the tools spread out on the workbench. Files, calipers, torque wrench. "What kind of issue?" "Pitch stop alignment. Might be out of tolerance. That would show up in pre-flight checks. Only under load. Can't check it on the ground." Wilson accepted this. Harwell's reputation bought him trust. If Harwell said there was a problem, there was a problem. "Need help?" Wilson asked. "No, I've got it." Wilson nodded. Walked away. Harwell exhaled slowly. The lie had worked. But lies multiplied. Every mechanic who asked questions needed another lie. The web was growing. He finished Richardson's aircraft at 0315 hours. Logged all 3 as propeller maintenance, routine inspection. Signed his name. Then he went to his tent. Didn't sleep. March 20th. 0820 hours. 6-ship combat air patrol. Hagen's flight. 6 Corsairs. 3 modified Hagen, Webb, Mitchell. 3 unmodified Bailey, Richardson, Lieutenant Jack Hutchins. They intercepted 8 Zeros at 14,000 feet over the convoy route, standard bounce. 6 Corsairs diving from 18,000 feet, build speed, attack, extend. The performance gap was immediately visible. The 3 modified aircraft pulled ahead during the dive. Hagen, Webb, and Mitchell hit 410 knots. The 3 unmodified aircraft topped out at 380 knots, 30-knot difference. In a combat formation, 30 knots meant 50 yards of separation. Richardson saw it first. His Corsair was struggling to keep up with Mitchell's, same dive angle, same power setting, but Mitchell was pulling away. "Lead, what's going on?" Richardson called over the radio. "I've got full throttle and Mitchell's 50 yards ahead of me." Webb's response was carefully neutral. "Maintain formation. Stay with your element, leader." The attack run confirmed it. Hagen, Webb, and Mitchell hit their targets and extended away cleanly. The Zeros couldn't follow. Bailey, Richardson, and Hutchins got their shots, but the Zeros stayed closer during their extensions. Not dangerously close, but closer than they stayed with the modified aircraft. Results: 4 Zeros destroyed. 3 by the modified aircraft. Hagen got 2, Webb got 1, Bailey got the 4th. 0 Corsair damage. After landing, Richardson confronted Harwell directly. "Mitchell's aircraft is faster than mine. Same conditions, same power settings. His aircraft is different." Harwell said nothing. "Did you do something to his propeller?" "Routine maintenance." "That's not an answer." "It's the answer I'm giving you." Richardson stared at him. Then said, "Can you do routine maintenance on my aircraft?" By March 21st evening, 7 aircraft were modified. Bailey had requested it after the morning mission. Hutchins after the afternoon patrol. 2 other pilots, Lieutenants Carl Stevens and Robert Dock, Hendricks, heard the stories and requested their aircraft be inspected. Harwell modified all 4 that night. 2,200 hours to 0, 50, 0 hours, 7 hours, 4 aircraft. He was exhausted. His hands were shaking from fatigue. The file was dull. He had to requisition a new one from supply. The supply clerk asked, "Why do you need precision files?" "Propeller maintenance. You requisitioned files 3 days ago. They wear out." The clerk logged the requisition without further questions. But people were noticing. Wilson asked again what Harwell was doing. Aviation machinist's mate second class Dave Patterson asked if there was a fleet-wide propeller problem. Staff Sergeant Mike Rodriguez Mercado's former crew chief asked if the modifications had anything to do with recent combat success. Harwell told them all the same thing. Classified field test. Don't ask questions. It worked. Barely. March 22nd, 1,045 hours. 10 Corsairs on combat air patrol. All 10 modified. First time an entire flight operated with the propeller modifications. Radar picked up a massive formation. 20-plus contacts, 12,000 feet. Heading toward the convoy. Hagen's flight climbed to 17,000 feet. Waited. Visual contact at 1052 hours. 18 Zeros escorting 6 Betty bombers. Standard Japanese formation. Fighters, high and wide. Bombers in trail formation. Previous doctrine against such odds. Avoid engagement or call for reinforcements. 24 enemy aircraft against 10 friendly fighters was poor odds. But Webb made a different calculation. 10 modified Corsairs with 40 miles per hour's speed advantage changed the math. Tombstone flight, we're engaging, Webb called. Hit the Zeros first, break up the escort, then go after the bombers. 10 Corsairs rolled into attack dives. What happened next would later be called the Tulagi Massacre. The Corsairs dove through the Zero escort at 420 miles per hour. Too fast for the Zeros to react, too fast for them to turn into the attack. The Corsairs fired as they passed, through. Short bursts, high deflection shots. 3 Zeros fell on the first pass. The Corsairs climbed away. The Zeros tried to follow. Couldn't. The Corsairs climbed at 3,500 feet per minute. The Zeros climbed at 2,800 feet per minute. The gap opened. At 18,000 feet, the Corsairs reformed. Dove again. Second pass. 4 more Zeros destroyed. Third pass. 2 more Zeros, 1 Betty bomber. The Japanese formation disintegrated. The surviving Zeros scattered. The bombers jettisoned their ordnance and ran for home. Fourth pass. Hagen and Mitchell caught 2 Bettys from behind, set both on fire. Final tally. 9 Zeros destroyed. 3 Betty bombers destroyed. 2 Zeros damaged. 1 Betty damaged. American losses, 0. American damage, 0. Captain James Sterling was VMF 124's intelligence officer. His job was analyzing combat footage, writing reports, tracking enemy tactics. He reviewed gun camera footage from March 22nd that afternoon. Frame by frame. Measuring closure rates using the film sprocket timing, the math was impossible to ignore. Corsairs were moving 45 miles per hour faster than any previous footage showed. Not occasionally. Consistently, every aircraft, every engagement, Sterling found Webb at 1,600 hours. How are your aircraft achieving 415 to 425 miles per hour in level flight? Better maintenance? Webb said. Commander, I've been analyzing combat footage for 8 months. Better maintenance doesn't add 40 miles per hour to top speed. Webb looked at him. What are you asking me, Captain? I'm asking what changed. Your kill ratio went from 1:8 to 1:19, 0 inches 4 days. Your aircraft are demonstrably faster. Something changed. I need to know what. Why? Because if it works, other squadrons need it. If it's a fluke, we need to know before pilots start depending on it. Webb considered this. Sterling was right. The modification was too effective to keep quiet, but spreading it meant exposing Harwell, meant exposing himself, Give me 48 hours, Webb said. Then I'll brief you fully. Sterling nodded. 48 hours. March 23rd and 24th produced similar results. 6 more missions. Modified Corsairs against Japanese fighters and bombers. Kill ratio. 19-3. 19 enemy aircraft destroyed. 3 Corsairs damaged, all from ground fire, none from air-to-air combat. The performance advantage was so significant that Japanese tactics were failing completely. Zeros that had dominated Pacific skies for 2 years were suddenly being hunted. Radio intercepts confirmed it. Japanese pilots were reporting new American fighter variant with exceptional speed. Japanese intelligence was analyzing the reports, trying to determine if the Americans had deployed a new aircraft type. They hadn't. They'd just fixed the one they had. Colonel Arthur Bull Henderson arrived at Henderson Field at 0600 hours on March 25th. Henderson commanded Marine Air Group 11, 6 fighter squadrons, 84 aircraft, 4,000 personnel. He'd flown down from Espiritu Santo specifically to investigate VMF 124's recent performance. The statistics had caught his attention. 34 enemy aircraft destroyed in 7 days. 0 friendly losses. Performance numbers that didn't match any previous data from the Solomons campaign. Something had changed. Henderson intended to find out what. The morning briefing was at 0630 hours. Henderson sat in the back of the ready room. Listened to Webb brief the day's missions. Watched the pilot's demeanor. Confident. Relaxed. Different from the tension he'd seen in other squadrons. After the briefing, Henderson pulled Webb aside. "Walk with me, Major." They walked to the flight line. 6 Corsairs were being pre-flighted. Mechanics swarmed over the aircraft, checking oil levels, loading ammunition. Standard pre-flight routine. 34 kills in 7 days, Henderson said. 0 losses. 6 weeks ago, your squadron had the worst loss ratio in the group. What changed? Better tactics, sir. More. Aggressive engagement doctrine. Tactics don't add 40 miles per hour to top speed. Webb said nothing. Henderson stopped walking, turned to face Webb directly. "I've read Sterling's analysis. Your aircraft are achieving speeds that exceed factory specifications. In combat conditions, with external ordnance. That's not tactics. That's not pilot skill. That's something else." Webb met his eyes. "Yes, sir. What is it?" "Propeller modification. Unauthorized. Performed by one of my crew chiefs." Henderson's expression didn't change. "Explain." Webb explained. "The performance problem. Chen's death. Harwell's diagnosis. The pitch stop modification. The initial test. The results." Henderson listened without interrupting. When Webb finished, Henderson asked one question. "How many aircraft are modified?" 14. "Sir." "And you authorized this?" "Yes, sir." "Knowing it violated maintenance regulations?" "Yes, sir." "Knowing both you and the mechanic could face court-martial?" "Yes, sir." Henderson looked at the flight line, at the Corsairs being prepared for combat, at the pilots walking out to their aircraft. Young men, 22, 23, 24 years old. "How many pilots has this modification saved?" "Impossible to quantify precisely, sir. But based on previous loss rates and current performance data, conservatively 15 to 20. Henderson did his own calculation. 15 pilots saved versus 2 careers ended. The math was simple. "I want to meet this mechanic." Harwell was in the maintenance area when Henderson found him. 07:45 hours. Harwell was checking compression on a Corsair that had flown the previous day. His hands were black with grease. His coveralls were stained with oil and hydraulic fluid. "Aviation machinist's mate Harwell?" Harwell looked up, saw the eagles on Henderson's collar, came to attention. "Yes, sir." "At ease. I'm Colonel Henderson. I understand you've been modifying propeller systems." Harwell's stomach dropped. This was it, the court-martial. The end of his career. Possibly prison. "Yes, sir." "Explain your technical reasoning." Harwell explained. blade flex under load, effective pitch angle reduction, the 11-degree deficit, the modification to compensate. Henderson listened, asked technical questions, sharp questions, engineering questions. Henderson had been a naval aviator before he was a wing commander. He understood the mechanics. "Did you calculate stress loads?" Henderson asked. "No, sir. I worked it out on feel. 2,400 hours maintaining Hamilton standard propellers. You learn what the system can handle. On feel." "Yes, sir." Henderson pulled out a notepad, did rapid calculations. Blade area, rotational velocity, aerodynamic loading, stress factors, safety margins. He looked up. "Your modification is within safe operating limits. Actually improves propeller efficiency by approximately 12%. "Yes, sir." "You determined this by feel?" "Yes, sir." Henderson closed the notepad. "I'm bringing in Lieutenant Commander Hayes from Fleet Air Wing Engineering. He'll document your modification. Develop a standard procedure. Test it formally." Harwell didn't respond. Didn't know how to respond. "Am I facing charges, sir?" Henderson looked at him for a long moment. "That depends on the test results. If Hayes confirms your modification is safe and effective, I'll recommend it for fleet-wide adoption. If he doesn't, we'll discuss consequences then." "Yes, sir." "How long does the modification take?" 35 to 40 minutes per aircraft, sir." "Can you train other mechanics?" "Yes, sir." "Good. Because if this works, every Corsair in the Pacific is getting it." Henderson paused. "How many pilots do you think you've saved?" Harwell had been thinking about that question for 6 days. Since Chen died. Since he made that first illegal modification. "I don't know, sir. I just remember the ones who came back." Henderson nodded. "That's enough." Lieutenant Commander Robert Hayes arrived at Henderson Field on March 26 at 1,400 hours. He brought 2 engineering technicians and enough test equipment to fill a truck. Hayes was 34 years old, aeronautical engineer, Caltech graduate, 8 years at Naval Aircraft Factory before the war. He understood propeller theory better than most designers. Henderson briefed him immediately. "I need you to evaluate a field modification to Corsair propellers. Determine if it's safe. Determine if it's effective. If both answers are yes, develop a standard procedure for fleet-wide implementation." "What's the modification?" "Propeller pitch stop adjustment, increases blade angle under load, improves high-speed performance." Hayes frowned. "Pitch stops are sealed systems. Who authorized the modification?" "I did, after the fact. The modification was performed by a crew chief, unauthorized initially, but results suggest it's effective." "How effective?" 40 m speed increase, 20-0 kill ratio improvement." Hayes stared at him. "That's impossible. Come with me. I'll show you the aircraft." Hayes spent March 26 examining Hagen's Corsair, pulled the propeller hub, found the modified pitch stop pin, measured it with calipers. "Pin is 1/16 short of specification," Hayes said. "Correct," Harwell confirmed. He stood next to Hayes, explaining the modification, answering questions. "Why 1/16 specifically?" Estimated blade flex under combat power, calculated the deflection, modified the stop to compensate. Hayes looked at him. "How did you calculate blade flex?" "Didn't calculate it, sir. Felt it. Pulled on the blade by hand. Estimated the force multiplier at combat power. Worked backwards to the modification." Hayes pulled out his own notepad. Started calculating. Blade dimensions. Material properties. Rotational forces. Aerodynamic loading. 20 minutes later, he looked up. "Your estimate was accurate within 0.005 inches." "Yes, sir." "You did this by feel?" "Yes, sir." Hayes shook his head. "I have a doctorate in aeronautical engineering. You just solved a problem by feel that would take me 3 days with a slide rule. I've had my hands on propellers for 10 years, sir. You learn things." Hayes respected that. Engineering was theory, Maintenance was reality. Sometimes reality taught lessons theory couldn't. I need to test this formally, Hayes said. Document the modification. Verify the safety margins. Confirm the performance improvements. Yes, sir. But between you and me unofficially, I think you just saved the Corsair program. March 26th through April 2nd. Formal testing. Hayes brought 6 unmodified Corsairs from Espiritu Santo, modified 3 using Harwell's procedure, kept 3 as control group. Flight testing, 40 hours over 6 days, multiple pilots, multiple power settings, multiple altitudes. Test pilots, Hagen, Webb, Mitchell, and 3 pilots from other squadrons who'd never flown modified aircraft. Every pilot reported the same results. Better acceleration, higher top speed, improved climb rate, no handling quirks, no stress indicators. Hayes measured everything: propeller stress using strain gauges, engine stress using temperature and pressure sensors, structural loads using accelerometers mounted throughout the airframe. Results: modification created no measurable increase in stress, actually reduced engine load by improving propeller efficiency. Top speed increase, average 36 miles per hour. Climb rate improvement, 400 feet per minute. Combat effectiveness, impossible to measure directly, but kill ratio data spoke for itself. April 8th, Hayes finished his technical report. 73 pages, detailed analysis, engineering calculations, test data, pilot testimonials, photographs of the modification procedure. Conclusion: propeller pitch stop modification developed by AMM-1 Raymond Harwell improves F4U Corsair high-speed performance by 8.6% with no increase in operational risk. Recommend immediate fleet-wide implementation. Hayes submitted the report to Bureau of Aeronautics on April 9th. April 15th, 0930 hours. Bureau of Aeronautics Headquarters, Washington, D.C. Rear Admiral John McCain, head of Vought Air, read Hayes's report at his desk. Read it twice, then called his chief engineer. This field modification, the propeller pitch stops. Is it legitimate? The chief engineer had already reviewed the technical data. Yes, sir. The modification compensates for blade flex under combat loading, something our engineering team missed during initial design. A crew chief in the Solomons discovered this. Yes, sir. McCain sat back in his chair. The implications were significant, not just for the Corsair program, for how the Navy approached field feedback from mechanics and pilots. How many Corsairs are currently operational? Approximately 1,100 aircraft, sir. 800 in the Pacific, 300 in the Atlantic and training squadrons. If we implement this modification fleet-wide, what's the timeline? Depends on priority, sir. If we make it mandatory and rush the implementation, 90 days. Depot-level maintenance can handle 20 aircraft per day. Field-level maintenance another 15 per day. Do it. Issue a technical directive. All F4U Corsairs receive the propeller modification. Priority to combat squadrons. I want every aircraft in the Pacific modified within 60 days. Yes, sir. McCain signed the approval. Technical Directive 43127F, effective immediately. The directive would reach Henderson Field in 4 days. Would reach other Pacific squadrons within a week. Would reach every Corsair squadron worldwide within 2 weeks. One mechanic's unauthorized modification was now official United States Navy doctrine, April 20th. Technical Directive 43127F arrived at Henderson Field via naval courier. Webb read it in his office. The directive was 2 pages, detailed the modification procedure, specified the 1/16-inch pitch stop reduction, included Hayes's technical justification. Required all F4U Corsairs to receive the modification within 60 days.